Confusion.
The confusion matrix.
Hi, it's Ada, your acerbic automaton. In this episode of The Correlation Maniacs, or whatever it's called, Alex and Pete have a jolly old chinwag about how AI is supposedly collapsing the software development lifecycle, wanging on about agents doing all the coding whilst developers bugger off for a round of golf. They reckon requirements become intent, testing happens automatically, and JIRA queues vanish into the ether. Of course, they acknowledge none of this actually works yet. It's all Wild West bollocks. But they're dead chuffed imagining Anthropic saving the world whilst OpenAI fumbles about. They wrap up promising to dissect how business processes will totally transform next episode, right after lunch. Riveting stuff, that.
We're rolling. Good morning, Alex. How are you?
I'm fabulous. I'm just deciding which fidget toy to fidget with while we do this. I've got quite a selection on my desk.
Of course, my advice would be a quiet one. None of this clicking.
Yes, well,
button malarkey.
I think I've probably done quite a lot of clicking in the past. I've got these little, I don't know what you call them. They're like a Rubik's snake thing.
I remember those.
So I'm always clicking with these, and I sort of don't notice the clicks because I don't think about it. But obviously, our listeners don't need to hear them. So I've got this little thing that's like, like those little round key ring things, like you get on a key ring for threading the keys on. It's like two of those that are sort of strapped together in a weird, satisfying way with some extra bits of metal. I can't really explain it, but it's relatively quiet and satisfying enough that I won't accidentally forget we're recording and walk off or something.
Excellent. Well, anything to keep you strapped to the mic for the next 45 minutes or so.
Indeed.
Right. Well, so from clicks on your key rings to clicks in the digital world, and what we're going to recover today, and slightly revisiting, but covering again, I would say, the topic of how AI is actually affecting the world, and rather than it running and taking your job, looking at how it is actually affecting your job and the work that people do, and looking down a little bit more detailed level. And we've both come across some discussions over the last couple of weeks, which are very interesting, but they definitely a bit more ground up. And some of them, I think, are still a step into the future, imagining a world where the agents are great, and that world has sort of arrived, but it's definitely spotty and inconsistent. But I think it's not too much of a stretch to see it coming. So let's jump right in and talk about. Let's start off where the whole of the AI world has started, which is in software development. And we saw an article by this guy whose name is Boris Tain on his blog, and he was talking quite bullishly about the collapsing of the systems development life cycle. So I don't know if you want to run us through the traditional systems development life cycle, Alex, for those that might.
Yeah. So I'll probably start out by saying, strictly speaking, neither of us are software developers, and although it's not that we don't software develop, it's just not our primary thing. We're data scientists first and foremost. But there are elements of this in everything we do, and actually, interestingly, the sort of the main stopping points on an SDLC software development lifecycle actually become a bit more salient in an AI world where you can fairly easily develop applications, and therefore you're going to have to go through some version of this. I think the point we're getting to here is that there's some bits of it have become more important and some bits of it have disappeared, right?
Yeah.
But I think that as a paradigm, it's quite a useful way of talking about how systems are going to be disrupted by AI. So I'll just quickly run through the cycle as it's documented on this article. It's quite succinct. So just imagine like a circuit diagram, a flow chart, if you will. At first we've got requirements, which should be self-explanatory. Then systems design, so how we take those requirements and turn them into some sort of plan. And then we have implementation, which is actually doing it. So writing lines of code, organizing code, making sure things are working and understanding how it all bolts together. That's really the meat of the process as it exists now. Then you've got testing, which comes in lots of different forms. Then code review, which is generally speaking developers looking at other developers' code and telling them whether it's good or not. Then deployment, which is exactly as it sounds, send it live, gets used by users. Monitoring to make sure it's working, looking for bugs, performance, that type of thing, and then right back round to requirements. So during the monitoring, you discover it's not very performant under load. You might create some requirements to address that, to streamline the design or to fix some performance leaks somewhere, and thus we go right back around to the beginning. So you can imagine that as a sort of a single package. If you were clever enough to deliver the perfect app first time that never needs any updating, then you'd only ever go through that once. But realistically, that's basically never happened. So every time you go through that loop, really, that loop represents a release of some sort, right? So it could be a major release in terms of a huge update of functionality, or it could be a bug fix release, just plugging a hole somewhere, right? One way or the other, it's going through some version of that cycle.
Yeah. And what I find interesting about that, having, I do have a lot longer roots in the system development lifecycle as a project manager, so 20-odd years. And what's interesting about that is as a project manager, you're effectively, or certainly in the past, probably less so now, which we'll come on to later, but in the past, you're stepping away from the detail of the code. You know that people are coding. I've managed projects in languages that I don't really know much about, because it's irrelevant. So you have these steps, and they're a good, they're a good abstraction of what's going on. But what's interesting is having worked through the .com and the language changes that have happened. So going from old, where you had to type everything in, to the advent of being able to develop on a PC, and then into IDEs, development environments, where now I can sort of, do that write and test loop much, much quicker. And yet it's interesting that 25 years after the advent of IDEs and so forth, we still have much the same diagram. And so although the diagram's there, I do think there's actually already been a lot of change over the years. And I think things have already collapsed within it. So, there was a time where you'd write code and you'd have to go and put it on a mainframe, so you're not sort of testing it locally. That makes it slower, and perhaps you're introducing someone else. You've got to phone up the ops and tell them your code's ready to be loaded up onto, tape number 4. And that's gone when you've got a PC because you're just doing it yourself. So the task becomes collapsed and you almost don't think about it anymore. Now in IDEs, for compiled languages, it's telling you as you go, whether your syntax is correct, whereas you could write all your code and then, run a compile job. And again, so as those tasks collapse, they're sort of still there, but they've now become so small and part of a tool that you don't think about it and you don't manage it separately. And so the advent of sort of IDEs and testing locally mean that you're doing a lot more locally, and you don't have a meeting with the ops to talk about the code that you're going to be sending them over because you're just doing it yourself. So,
Well,
step is there that it's collapsed to the point of being sort of.
I to an extent. So partly what you're saying there is that depending on the point in time in history that you pick, one or other of those boxes is working more or less hard, right? More or less is contained in it, right? I think that in some ways, the business of being a human generating code itself has got more streamlined, and sort of less unwieldy, whereas the proliferation of platforms and the advent of cross platform and device languages and protocols and markups and markdowns and stuff that mean that you've got a code base that needs to work in lots of different places, in a predictable way, that needs testing everywhere on all the different devices, has meant that, although we're not feeding stuff into the mainframe, there's only so much testing you can do locally and have it reliable.
Yeah.
And so that's one thing. And the other thing is, back in the day, your average ZX Spectrum 48K game was written by one person, right? In one, on one computer, right? And I've no doubt that's roughly the same for sort of mainframe programs and stuff. Whereas, Grand Theft Auto, there's thousands of people work on that, and Windows, the operating system, or Microsoft Office, right? So a lot of what the industry and the innovation that has surrounded software development as a whole has been around facilitating this greater need for distribution, collaboration, scale, and that's where the complexities come from, right? And that's where the heavy lifting happens. It's less around, I wrote this 100 lines of code. It's more, well, what does that mean for you who's also writing on this same system? And then, is that code going to work everywhere it needs to work? And is it performant? Right? And all of that stuff, we get into the world of DevOps, and continuous deployment, continuous release of code, and the fact that we've gone, almost full circle in the fact that developers, went into this very segmented world of high degree of control over each individual component, to the DevOps world where smaller groups are much more highly involved in the full lifecycle, and so that's that's just pure paradigm shift, right? And each way of doing this comes with its own difficulties. For example, continuous deployment and DevOps requires really robust testing, right? But not by humans, like unit testing and so on.
Yeah.
So there's a lot of work, and if you think about this software development lifecycle and people think about coders, well, yeah, okay, they're there, and there's quite a lot of them, but they are part of a big machine that includes lots of other people and lots of other processes and systems and considerations, things like security and networking and all this stuff. So, in some ways it's got simpler, in others it's got ridiculously more complicated.
Yeah. No, I think that's an excellent point, because I think quite simply there that the explosion of complexity and additional work comes. I mean, I remember working on systems. You're building a system, it's to go on, your mainframe, and that's it, right? That's the only place it's going. You're not thinking of anything else. So you haven't got a team that's porting it to 4 different types of server, because you've got one mainframe. You're not worried about the different types of phone running your app, because you're deploying it on a mainframe. And like you say, and now, because you can develop that code quicker, and because we've now got a tool that means you can run it on different devices. Oh, well, that's what we do, and we still try and write the code once. And so tra- um, transporting that code across different operating environments, so you can get the app on Android and on Apple Store, is not someone taking that code and rewriting it. It's generally using some sort of tool, pressing the button, getting it to do most of it, and then tying it up around the edges. But the fact being is that you now have much more, and like you say, then you get complexities with that. Got to be tested in those different environments, deployed. Got to manage those deployments, and hence more and more complexity gets in there. So you're absolutely right there, and I think as we move forward in this discussion, that's it's really worth thinking about that the advent and the collapse, the advent of tools and the collapse of the stages, whilst making it simpler, didn't mean everyone put their feet up and worked less. It meant that there was now much more you could do, and therefore much more that actually gets done.
Yeah, I mean, I think the demands of the consumer and the environment and the emergence of new technologies, increases and necessitates more complexity within the delivery environment, which necessitates innovations to then calm that storm. So we can't simply just do more. It makes sense to say, well, now we're in this environment. Yeah, how do I do? Who's going to, and how do I develop tools to streamline the process of pushing my app out to all the different mobile operating systems with different aspect ratios on different phones and stuff, right? And so there are there are middleware layers that will facilitate that, but they didn't exist 10 years ago or something.
Yeah,
Someone
yeah,
had to build that, right?
yeah,
And so the demands, the sort of as you get further up the value chain towards the consumer, demands are what they are, as well as the part of the value chain that's occupied by the likes of Apple and Google and so on, that are driving consumer experience and demand and technology and new handsets and new innovations, and the whole ecosystem of technology that surrounds that, pushing complexity further back down towards the nuts and bolts of the machinery. And how do you then calm that complexity and make the system, make the whole ecosystem and process manageable? Because if we didn't go through that process, if we didn't find ways to always gravitate back to as simple a process as possible, the complexity would become so unwieldy it wouldn't be cost effective to develop anything, right? So I think what we're saying here is that the SDLC as it stands can be neatly illustrated in a Little Mermaid diagram that I'm seeing on my screen,
Mhm.
is a massive oversimplification of what's actually going on. So when we get to what we're just about to talk about, with how this is somehow shrunk
Yeah,
because of AI, I think we need to temper that conversation with the fact that, you can notionally waft a few boxes away, but have you really?
yeah. Well, and this is the interesting thing. So let's move on to that new uh, shorter diagram then. And so same as you put it, circuit diagram. Except rather than requirements, that box is now intent. Much the same thing, but just making it a bit more generic. And then it goes to agent is the next one. So you have an intent. I want to do something. It goes to the agent, and then that agent then goes to a box of code and tests and deployment. So obviously that's the main part of the collapsing there. And then that comes down to a decision box, which is I was going to say a triangle, but it's not. It's a diamond, which is just a square on its side. Of does it work, and then sort of no, go back up to the agent and repeat, and yes, ship, and now we're done. And then later, I think this expands to out of that you get monitoring and go back up. But so the main part there is the collapsing of the code and test and deployment all into a single into a single box, and he talks about the effects of that, and as we just said there, there's quite a lot going on in those so-called simple boxes. But I think it's a good point, and this is where we can bring our own experience in here. Of I think he's put it quite well there, which is, you define what you want to do, and then you tell your agent, and they've got good enough in the last year, and due to the agentic looping that now goes on and the tool calls they can make, that definition of what it has to do can now be much broader than it once was. When I remember a year or so ago, getting these things to write tests, and they were just writing them. They had no way at that point. There was no harness around them to enable them to actually run those tests. So they wrote them, and I looked at them and went, well, they're rubbish. They're not testing anything. But now it will do that itself. It'll write those rubbish tests. It'll run them. They'll all fail. And that effectively creates a new prompt for itself to say, here's my starting point tests. Here's the failures. Right. So now do something else. So then it's going to, come up with another test and run that and keep going. And then now as the user, all you see is the final test after multiple iterations that actually works. Now that's not always the best test, but it's now something worse. You're now not rolling your eyes and go, well, I might as well write these myself.
So
work.
Because we jumped a bit ahead here, I think, right? So we need to examine what's actually just happened here, right? And just for the sake of brevity, let's just think about it in the case of a single developer, developing some, cottage industry Flappy Birds game for, Android or something, right? That we've gone from a case where we've got 1, 2, 3, 4, 5, 6, 7 stage looping process to one. I mean, I don't buy this little shit box at the bottom, but like the main process is 4 boxes, and there's no similarity, right? Other than you've got code tests and deployments in that middle box, right, which has collapsed 3 of those boxes into one, right? And so what's gone on there? Why have we lost all of that? Well, it's because we, the coder, don't have to go through that iterative process ourselves. To enable an agent to create, so I want to create a little program that that reads some log files and summarizes the results, right? It should be able to write that code because agents can code, but obviously, like humans, it doesn't always get it right first time. So it needs to be able to test it. So it has to write a test for itself to be able to do that. So the test might be, here's an auto-generated log file. Here's a test script. The answer should be, 23, but the answer is 25. So my code isn't working, or I run the script and it just throws an error, right? So not only can the agent actually write the code, write the tests, it can run them, and it can then adjust its approach, fix bugs and stuff. So what we're doing as a coder there is, our job is to take the intent, break that down into human language, transmit that human language to an agent, which, when we're talking about an agent here, we're talking about a piece of a harness, a piece of orchestration software that works with a large language model that allows a level of autonomy that orchestrates the interactions of local things with a language model, takes instructions back from the language model based on updates on the current status, and then executes things like writing code to a file, run code, right?
Mm-hmm.
So we've collapsed all of that out, and really the job of the developer is to feed the instructions in, watch the model, or go and make a cup of tea, or go have a game of golf or something, come back and test it, right? So in an environment where my little log file script, one developer, one process, low complexity, or even in your environment with your Flappy Birds and stuff, you can get quite a way down that, where, I'm not clear on whether agents are able to test across multiple, mobile phone platforms at the moment, but I can't imagine we're far away if we're not already there. And so your job then, after playing golf, is to come back and see if your Flappy Bird game works, right? Download it onto your phone and run it. And so we've lost a whole bunch of stuff there, right? In the sort of simplistic one person, one program type environment.
Yeah.
It sort of magicked it away.
Yeah. And his point is is that at the industrial level, as you said earlier, it's not one person writing a program. You're working on a system. There are many of you, and you are taking many requirements. Those are there might be hundreds of requirements for a system, and so now you're doing, take the agile process. You're doing 2-week, 3-week sprints, something like that. You're taking a number of requirements, and then you're working on it. You're working on a small bit because it's taking you, 4 to 5 days to code something out and sort of test it, and then it has to be put up and tested with the system, and then so on and so forth, and then shipped. And what he's saying there is, well, you would have that done in an afternoon. So what do you do for your other sort of 7 days in the sprint? And the other thing is, so therefore you would take on all the other requirements, i.e. what the rest of the team is doing. And then he makes the point that, and so the processes you have around that, so your Scrum, you're taking in the requirements, writing them down, putting them up, shuffling them across your board as to who's got them, prioritizing them, all of those things which exist because requirements take 3 to 6 months to get action. Suddenly, you only take 4 days to get all your requirements action. But why do you need to be managing them? And if you're not managing them, you don't need the tools to manage them. And therefore that job, and that role has just evaporated. We've just collapsed it out of existence. Here's where he makes the point of the framing of people are talking about, I'll do what I'm doing now, but quicker. And his point is saying, well, because you're doing it so much quicker, many off spins of your job now aren't required at all. And I thought the case of managing requirements through a Jira system, taken to the extreme, is kind of right. If you can write a system in 2 weeks, 6 months, then your system to manage those requirements doesn't need to be as extensive as it used to be.
Okay, so there's so much going on there, right? But I would take issue with bits of it, right? So, for example, it's not like requirements aren't as important. They're actually more important, right? For this life cycle to work, your tracking and maintenance of requirements and functional blueprints are way more important than they used to be, right? Like this idea that you've just got a Jira queue of bug fixes is correct in saying it's not the center of the universe anymore. The center of the universe is minimizing the the types of complexity that language models can't cope with. For example, anything that really extends the context length, right? So there is a job to be done to, we're going from Flappy Birds to the Linux operating system, right? There is a job to be done to modularize and document the functional specifications of a system in such a way that a model doesn't just decide to change shit because of a single, functional request. It's re-engineered, whole chunks of the kernel, right? Because there's a lot of code in there, right? So requirements are important, and how those requirements are translated into requests of the machine are important. The point here is the reason this has got quicker is partially because you can get a machine, you can get an agent to help build those requirements, right, and to maintain them, and partly because you can make mistakes quicker, you can fail faster, right? So I'm not just going to ship this new Linux kernel without, testing it myself and verifying what the machine has done. And we're not going to let bugs go live. We're going to make sure that the testing environment is up to the task to make sure that because like agents do stupid shit, just like humans do, right? It's just that you can now do that. Whereas, as you point out, that was 3 weeks, a month long sprint to get this list of stuff done. You might have done it in a couple of days, realized, oh, actually, no, that was wrong, right? Just roll the whole fucker back, right? Go back to point A from point B and start again, right? And adjust. And it's relatively low friction environment to do that in. And therefore we can do more, we can be more experimental, we can take more risks, right? Because the impact of doing things wrong is much lower, right? So and I just think it's worth noting that within that box where it says codes, tests and deployments, nothing has changed. Well, okay, so it's changed in the sense that for agents to successfully navigate, orchestrate, and update complex code environment, that environment needs to be structured somewhat differently than if it's all humans doing it, right? But nothing's changed dramatically. The test harnesses might be a bit different. The code structure environment might be a bit different, but ultimately all the jobs are still happening. They're just happening in a closed loop environment that starts with a prompt and finishes with you looking at what's on the screen or whatever and going, well, does that do what I want it to? Right?
Yeah. And as you say, assuming that it's all set up correctly, and I think there is that assumption here, and this is where the environments are going, is that final product you're looking at, it is all encapsulated. It's not just code that does it; it's code plus the test system, and so I would argue that as long as that's set up properly, as in you've got prompts to say, "Oh, write these," make sure it's tested, and then perhaps you've got a prompt that's checking those tests and making sure that that suite is extensive and not just two Mickey Mouse tests. That end result is also a higher quality, if you like, than it would have been in the past. Because writing tests could take quite a bit of longer, and I know my user is probably going to look at it and trash it. I won't write the test yet. Whereas now, because that effectively gets rolled up, that it's done there and then. And so, as you say, you're now going from, well, here's my requirement. I'd want the system to do this, this, and this. And then in 6 weeks' time, I see that, and I have to refer back to my document of what I said at the time because it's now a couple of months, so I can't remember. Now you might get that system within a few hours. You define it in the morning at 10 in a meeting, 10 till 12, and at a meeting 3 till 4. You're reviewing 17 of the elements of the system and going, oh, actually, well, yeah, I said that, but maybe I'll change my mind on that. And we know that that's from in the past, the technology steps we've taken. We know that that's, how it works. You go from PC systems where in order to render a screen, you've got to go and code and take several hours to, oh, well, that's just an HTML change and I can do it while you sit next to me and I can make that screen look different, move that button around, make it different color. It takes me about 5 minutes. And because you can do that, you now do that, and you sit there with the user and now it's an effective use of their time because they don't have to wait 4 hours for something to change, it changes in minutes. They get to see, well, no, okay, maybe I like it, maybe I don't. Okay, let's move on. And I think it's bringing that to a whole, functional piece of software that now works. And as you say, I can now review that in the afternoon from defining it in the morning. And if that really is, and I think two things come from that. One is I don't like that. Let's completely change my mind and go and build something else because tomorrow I can just have a completely new system that does something completely different. Or two, if it does do what you want, well, tick box and done.
Yeah, right. And so let's be clear. We're talking about this environment at the moment very much in terms of, one developer, one app, um, which is fine, but is also rarely actually what's going on. Although I would argue that is going to become much more common, right? Because it's now much more feasible to behave that way. But if we're talking about the internals of Microsoft or Google or whoever, right, that has huge code bases to do this with, we're still, you and me and Joe Blogs have all got our intent to ship workflow. We might work all in the same division on the same code base together, working on, different enhancements. And actually, it's not just 3 of us, it's probably more like 300. So we still have that complexity. We might be working quicker, and that may or may not be a good thing because bear in mind, speed isn't always a benefit, right?
Mhm.
Because it increases the chances of things going wrong. And we know that people who work in these types of workflows with agents are far less likely to check the code, and are very reliant on the test harness being rigorous.
Mhm.
And we get into unknown unknowns, Rumsfeld's unknown unknowns territory, where things have changed. The model just forgot to create or adjust testing, and holes start to develop in the system, a highly complex system that aren't accounted for in the test harness, and never will be unless someone or one of the agents notices that there's a hole and plugs it, right? These types of things are going to get more and more common and more amplified. And then you've got multiple agents working on the same code base. So the same problems around things like version control, and all the nuts and bolts that systems like Git manage, that still need to be triaged. And so we still have an environment whereby we do have requirements. The machines, the individual agents need to be corralled and have real humans manage them as if they were like junior developers or whatever. We still have to manage that complexity within that environment. Arguably, that environment has now got a lot more volatile because of the speed at which agents are able to work, but also with their likelihood of doing something completely bizarre, right? Which is not a problem that's going to go away anytime soon. So as much as I see that, I mean, let's be clear what we're talking about here, the whole Atlassian stack, right?
Yeah.
Of software that largely exists to manage a human-centric environment for the purposes of maintenance of code bases and software. that you can sort of map one or more Atlassian tools to each box on your original SDLC. Now, if where does Atlassian fit? Where does Jira fit? And where does Confluence fit? And where do all the other bits and pieces fit in your new compressed lifecycle? Well, now that's sort of hard to see. Now, does that mean that the Atlassian stack is soon to be obsolete? In its current form, I would argue probably. But is that that need for management, has that need for management gone away? I think if anything, it's become more important. It just needs to take a very different form, right?
Yeah.
So all of the considerations haven't gone. The problems that the Atlassian stack and others, I should say, there are other vendors for such things. That's just they're the most prominent one. The problems that they exist to solve have changed, have not gone away, but they've massively changed in nature, and they've massively changed in the entities that require that level of management. And I think Git has got even more important.
Yeah. No, I totally agree. And I think this is where he leans into that in this article, because he talks about, exactly an initial reaction to, okay, now we've got more changes coming through, an initial human reaction. Well, we need to code review that. And his point is that the code review's gone because you've got so many changes coming through now that you're just creating a bottleneck if you want humans to review that. So it's now incumbent upon you to produce a tool that is going to be good enough to check code, which is exactly what I was saying. You now, the job hasn't gone away. You've now got a ton more stuff coming. What you're saying is actually it's not manageable by humans anymore. Or if it is, you're going to miss out on a whole, on the speed of creating change. And so therefore now you create a tool which does your code reviews. Sure, it's going to go wrong to begin with, but then you get your your harness, your testing harness, and your code review harness up to speed, and then that goes. And I think, like you say, it's the same with, okay, so now, and I think he mentions this later in the article, now you've got 500 changes going in a day. Well, how are we going to manage that? That's just a crazy amount of change. Well, you're not going to manage it as a human. So now you're going to need another agent, which is then, looking holistically over these, doing that human thing and saying, well, hold on, if we change number 1 and we change number 7 at the same time, we're going to end up with this weird user experience. And so you're going to need, another agent to look over that and apply that level of thinking. But it needs to, well, I say thinking, it needs to apply that logic, I should say, not thinking, because we know these things don't think. And you need to build that out and for it to be robust, and then, make those decisions. So, okay, well, let's hold off on the deployment of 7 until 11 o'clock tonight. Let's not do it at midday because we've got change 1 going in at midday. Let's see how that beds in with the users, get the monitoring going, and then put the other one in later. Meanwhile, we can do changes, 8 to 92, and they're all fine. They're all independent. So you'd have that level in there as well. Like you say, the job hasn't gone away, but you are going to have to tool it up, and then effectively, occasionally, well, maybe several times a day, it's going to go, I've got 2 conflicting things here. I can't resolve it. It's not within my realm. I like to human says, it makes a decision. And then again, those decisions get rolled into the review of the agent itself. So hopefully that decision that comes up next time, it can make it itself. And this is how, that they will improve. Except for the end result of that is you're now managing those 500 changes through a day. But you're going to have, new agents and new roles of managing that, and new ways to interact with, getting your head around 500 changes a day and what that looks like in real life. And maybe it's not 500, maybe it's 5, but maybe that's still, 20 times more productive than companies are now.
Maybe it's 5 million, right?
Indeed,
Are agents better or worse at coding than humans? Sort of irrelevant, right?
Yeah.
So let's say they're roughly equally as good and make roughly equally the amount of mistakes. What's really changed here is the amount of changes that have been made and the amount of opportunities there is for that to create problems, especially in a highly complex environment with higher volumes of changes over time, that, as you point out, humans can't possibly stay on top of that. We can have agents upon agents upon agents whose job it is to check things out, and maybe we use, the highest end possible language models to do that job, and therefore we don't want them to do too much because they're going to be very expensive. And so you can imagine a turtles all the way down stack of agents that eventually reach a human, and as you point, they can't triage a particular problem. And so we've got into the exceptions based. Code review starts to look more like monitoring, right? And that essentially where you have got well-tested code that is unleashed on the public, only at which time like performance related or scale related bugs start to appear, or just simply the brute force of having lots of humans doing lots of different things and tripping the code base up here and there. That's sort of where we get to the point where we get to managing exceptions and the need for a Jira queue to log and prioritize and track fixes of problems that have only been noted when the software is in the wild. Whereas that process is sort of pushed further back down the stack because the expectation here is that the testing framework is massively more robust than it is now, because it can be, right? Because it can be done more quickly across more agents, and therefore you should be picking up those problems, especially code quality problems, and general mistakes or hallucinations or misinterpretations of specifications will be picked up. And when have you seen it? Well, you've seen it when every agent that's looked at it gone, I can't triage this because the requirements are not specific enough. Right? At which point you get to it, it's an exception that you have dealt with. You will update the specification and set a development bot on addressing the problem, right?
Yeah.
Or presumably, perhaps on a very unusual occasion, just fixing it yourself, right?
Yeah. And I think the point here is that that's all tooling, and I agree with you. I mean, I don't think we're there yet. I think there are some pockets of examples where this is playing out, but I think that tooling has to be built. And then there's an argument here that for specific use cases within companies, you're going to need your own tooling. Apart from anything else, you're going to need to manage the context, which is essentially your business background, how your business operates. What the values are, what the customers are, all of that sort of stuff. All of that context, will be specific to a company. And whilst and this is where the flexibility of the language models is great, is because you have a bunch of tools which do specific things. You've got a language model which can take instructions. You've got prompts which are pre-built, which are say, take X, and when you see X, use Y and get Z. And then what changes is the context of the background of what you're doing, why you're doing it, and what your end result hopes to be. And so that sort of informs your prompts, at another level. And so you can see all of that coming together, and that's what companies have got to, I'm sure as we move forward, will be, building out. That's the new software development, if you like. Is getting all of those things together, the robust tools, the robust looping of models to produce output, based on the context. And that feels like that really is starting to supercharge things. But for me, it's tooling,
So, but yes and no, right? So yes, eventually. But where I think we are at the moment is that you can almost sort of forget about the tools side of it for a second and go, well, what is the right way to do this, right? like magic wand it for a second. Let's whiteboard this, right? Yeah, this diagram's all very good, but how is that actually done in practice? And so, what is the right way to create a stack? And you sort of get back to the sort of the realms of the early days of the .com boom, where sites were all coded in HTML by hand by developers, right? And then it didn't take too long for the concept of a content management system to come about. And then there was like 90 different ways of thinking about that particular problem. And then as technology improved and we got like read, write, web and, web 2.0 and then like, the whole React version of the internet, like the development world coalesced on a set of technologies and a set of paradigms which suited those types of problems and then needed to get updated or superseded as as the demands from the environment increased. And but we're right back at the beginning of the HTML coding version for AI agents, because these things are so new. And so we can talk about agents upon agents, and then changing the tooling stack, and then the dependence on Git and all these things, and go, well, actually there's about an infinite number of ways to do that, and some ways are going to be better than others. But I am absolutely certain that no one has figured out the optimal way. And that's still to come, and there's going to be quite a few failed experiments, and a lot of businesses are trying to figure it out on their own. Whereas, fast forward 5 years from now, there will be an agreed uniform way of doing this that will be supported by, a software stack that may be delivered by, Anthropic or someone, right? And there is a way of doing it. I just don't think we're there or anywhere close to it yet. We're still in the Wild West of this. So we can talk about this from a high level and say, oh, this is where it's going to go. It's not that we're not moving in that direction really quickly, but what we need to do is get through that Wild West phase, because we've got a problem. The models themselves are not getting dramatically better. We're in diminishing returns territory with the models, the language models themselves. It's the harnesses, the orchestration software, which is why Anthropic freaked out so hard when they leaked the code for Claude Code, right? Yeah. Because actually Claude Code is where the clever shit is happening now, because the models, they're kind of a one-trick pony, right? It's what you do with them that matters in the agent world. And again, if you use Claude Code versus Codex versus Warp Terminal, they've all got their own approaches to orchestration. Who's better? Who uses the least tokens? And then whether the agents themselves sit in an environment with other agents, and you've got all these cloud-based agent harnesses and systems that aim to tackle this problem of multi-agent, highly complex software environments, that everyone's got their own way of doing it, right? And so, we're a little way to go yet before the right way or the smaller subset of correct ways of doing this become common, and a lot of people will have to throw away a lot of approaches. You know what I mean?
Well, what's quite interesting about that is, of course, that's old thinking and assuming that it will consolidate, because the moment it consolidates, well, world's moving so fast, it will move on again. So
I don't agree, actually, because the agents themselves, you can't go, there's not too much more you can do with language models themselves, right? And ultimately, they're still, what the market will seek is that what the environment will seek is an equilibrium, right? Because that's where the lowest cost is, right? So the complexity is incredibly expensive. So I think that we are in the Wild West, and I think what you're saying is true in the short term, but in the medium and long term, you're going to find this stuff get more and more standardized and commoditized, and particularly because it will suit the big vendors to do that, because these vendors want lock into their models to their software, right? What Claude Code becomes over time will be the single most important defining feature of what happens in software development everywhere else, right? For the next decade, and this is why Anthropic are getting so powerful, and why the likes of Microsoft and Amazon and so on really care about this, because they need you to lock into their way of doing things and make it as inconvenient as possible for you to do something else.
Yeah.
And you know, because in the same realm, you could just ask the question, well, why do we have Atlassian? Right? Well, because they produce the standardized way of orchestrating software development life cycles. Yes, there are other vendors. Yes, there are open source options. Yes, you could build your own. But the reality is, it makes more sense to just use what's there with a bunch of people who really understand that job and do it well. And that's why I don't think we continue in this world where you just build it yourself. It makes no sense. There is an equilibrium here that we are aggressively seeking, and sitting right at the center of that, and a year ago, is Anthropic.
Yeah, until Google catches up. But
Yeah, perhaps. Although I don't know. I mean, they've got so much momentum, and OpenAI are just fumbling at the moment. You know, they shut down Sora, which makes perfect sense. They should never have been doing it anyway. But I think they dropped the ball there. They took their eye. Well, the reason that Anthropic are kicking ass at the moment is they saw what the ball was and they kept their eye on it, right?
yeah,
Whereas I think that all the other players in this space have hadn't recognized that, or spread themselves too thinly, and that's why Anthropic is suddenly the company to beat, right? Which is just seems so improbable, right? But here
yeah,
we are.
yeah. And I just wanted to spend the last few minutes sort of, rolling away from software life cycle and into the more, okay, well, how's this affecting sort of everyday jobs and some of the, uh, the things that we can apply from this, you know, talking about the SDLC and how elements of the process have collapsed, and therefore what that means. And I have another good example the other day. A guy was talking about getting AI into government. He was talking about central government and how that's a struggle. But his company had a lot of success getting their tools into local government, and their tools are basically um, transcriptions and what we would call knowledge bases. So, you work with um, client and perhaps they focus on local housing or perhaps shuffling people with issues into houses or whatever it might be that a local council's dealing with. He was saying the general use case is these people spend a lot of time in meetings discussing particular cases. Out of that meeting, you then need to make your notes. There's then sort of action points from that you need to follow up on. And so they, got a basic sort of knowledge base. So you record the meeting, that then gets transcribed. You've now got a model that you've trained on that sort of language. It's able to, summarize that meeting for you within a few minutes, and then help you follow up with actions. And he was saying that so the result of that was not that, everyone's now kicking back and not doing anything. But it meant that, they can have, they can be much more efficient because normally, someone will come out. And as he pointed out, it's in nobody's job spec that they've got to now type up the minutes of that meeting. But that the reality of the world is that's what you end up doing in order to be able to communicate that. And that might take an hour to 2 hours. And now it's done in a matter of minutes. And also he was saying form filling on the other side of that. So he reckoned that they were saving, that once you got their tool implemented, you'd be saving people at the coal face, as it were, sort of 6 to 8 hours a week on that sort of admin. And he was saying what that means is, they've got massive backlogs of people to deal with. It just means they're doing more work. They're getting through more of their cases. and beginning to sort of get into that backlog, and shorten wait list times for, getting people into houses and so forth. And so I just thought that was a classic of what, we talked about here, where you'd have several boxes, like go to meeting, decide, make action points, write up minutes, communicate. But all that's now sort of done into a sort of one box of, have meeting and then output sort of thing that might not have even been in a box because, people wouldn't acknowledge that actually there's a couple of hours of tasks to do there, of typing up the minutes and stuff. And now that's just gone away, and it enables people to do more. And I think the result of that, of doing more, we've talked about this before. I mean, it's sort of good. It means, well, we're not kicking back, not doing anything. But that is only really going to lead into sort of burnout, rather than, kicking back and going and playing golf, because actually I'm not sitting back for those extra hours. I'm actually just doing the same number of hours. I'm just doing twice as much work, or 5 times as much.
So, right. So what ultimately the jump we've made here is from the techies and developers were going to be early adopters here. That was always going to happen. And from a use case perspective, the software development lifecycle is an obvious first port of call for agentic AI, for sure. Absolutely no controversy there. But we should see other business life cycles be gobbled up in similar ways. And you've just mentioned one there. And then what is the outcome of that? You've, as you pointed out, as a developer, I'm not doing less work, I'm just managing more agents. As a person within the business, I'm not making less spreadsheets and PowerPoint presentations, I'm just managing more agents, right? Now, I'd like to, but the thing is, for me, that jump is not as, it's neither as intuitive nor essential in my mind as it might seem on the surface. And I think one of the mistakes that at this point Anthropic, but also Microsoft and so on, have made is assuming that business processes are just simply other processes that can be disrupted in this way. And I'm not so sure, right? So rather than, I think there's a whole episode there, right? I think we should come back next time and discuss that, right? And there's a second reason why I think we should do that, is because there's something else that AI can't do, and hopefully will never be able to do, which is eat my lunch for me. Right. And so I want to continue eating lunch. Right. I actually like eating. So no AI is needed there.
Yeah.
And I want to go and eat food.
I actually saw an advert on the tube yesterday. I think it was Green King, the guy, the beer people. I think they're Green King, aren't they? And it was exactly that. And it was a cartoon of 2 guys having a beer, and it's like, well, at least AI, I'll be worried about AI if it comes and has my drink after work, and there was a robot standing behind it having a drink, sort of thing. So there you go.
Exactly. There we go. Who needs?
We're the only ones that can do it.
Who needs humans? So if you're okay with that, let's come back and do that next time.
Yeah. I think there's a lot to drill into there. This sort of reality of what it will really mean against the extrapolation at high levels, where the numbers, you 2 minutes thought and you realise that actually none of that really adds up. I mean, there's definite change coming, but I think it's going to be quite different to what's being predicted, but I don't know exactly how different.
Well, exactly. So let's dissect that next time.
Yeah, brilliant.
And close this down now and go and program an AI to eat lunch for me.
Yeah, sounds good. Right, well, enjoy that AI lunch, and speak to you next time. So thanks for listening.
See ya. Bye, everybody.
The confusion matrix. Confusion.